Hello, and welcome to the Professor Podcast with Ruth and Claire. Each episode, we talk about a particular topic in the life of a professor. Ruth is a STEM coordinator who works to improve access to education at a large university in Ireland, and Claire is an associate professor at a primarily undergraduate university in Northern California. The purpose of our podcast is reflection, so we bring something we think is working and something we're working on to discuss. Welcome to the Professor Podcast with Ruth and Claire. I'm Claire.
And I'm Ruth. And in this episode, we're excited to share with you a discussion we had about science communication with two people who have thought a lot about communicating science. Shahir Rizk, Associate Professor of Chemistry and Biochemistry at Indiana University, South Bend, and Maggie Fink, Ph.D. student in microbiology and bacterial behavior at the University of Notre Dame. Together, they host a science communication workshop, and they're working on a popular science book about proteins that is scheduled to be published at Harvard Press.
I met Shahir a couple years ago at a Cottrell Scholar Conference, and this past summer at the same conference, we happened to get talking about science communication and had an interesting conversation about it, and I really like Shahir's ideas and insights, and it occurred to me that this would be a great thing to discuss on the podcast.
In this episode, Shahir and Maggie tell us about storytelling, fostering fascination, and treating people with dignity. We hope you enjoyed the discussion.
Well, welcome to the podcast, Shahir and Maggie. We are delighted to have you on the show.
Thank you so much. We're very excited to be here.
Yes, welcome to the podcast. And can we start with who are you? So can we start with you, Maggie?
Sure. My name is Maggie Fink. I am a Ph.D. student at the University of Notre Dame in South Bend, Indiana, which I was also born and raised here. So happy to be doing my Ph.D. in my hometown. So I study microbiology and bacterial behavior, and I've been working with Shahir for a few years now.
Oh, lovely. And Shahir, will you tell us a bit about yourself?
Yes, my name is Shahir Rizk. I am an associate professor of chemistry and biochemistry at Indiana University, South Bend. And I also teach at the IU School of Medicine. I'm a biochemist by training, and I have been working with Maggie for a few years now on various forms of science communication.
Lovely.
So what are some of the challenges to communicating science that you've come across that maybe have led you to run your science communication workshop together?
So we both have interacted quite a bit with non-scientists. My own family, I'm the first person to go to college in my family. So kind of interacting with people who are not trained as scientists has been difficult. And I think the pandemic has really highlighted that, even though Shahir and I have been working on science communication before the recent pandemic. But I think there's just a general lack of trust with scientists and from the general public. You know, we're kind of viewed as these other robotic type of people who are out to get you and are in cahoots with, you know, government or big pharma. So there's a lot of lack of trust. And I think the spread of misinformation with the internet has also really caused a lot of problems with the ability to get good information out there in a way that's effective and engaging. And I think those are some of the biggest challenges. And I know Shahir and I were talking about this yesterday. You have a couple of others that you'd like to include as some of the bigger challenges as well.
Yeah, I mean, that obviously misinformation is a huge part of it because, you know, this misinformation spreads much faster than sound information, as many of you might already know. The other challenge, I think, is just the different language that we speak. You know, we as scientists have come up with shorthand language for within our field that basically it makes it really difficult for people who are not even within our own field to understand each other. So the idea of just having jargon and not being able to explain exactly what it is that we work on there's a communication barrier essentially between us and, you know, other people in the community. So that's a huge challenge as well, because it's almost like we have to untrain ourselves on how to speak as scientists to be able to speak to somebody else, even just outside of our field, let alone somebody who doesn't have a science degree.
Oh my goodness. Sorry, Claire, I have about 25 things I want to say about everything you said. That's so interesting, and it's so It's so funny you're saying about the jargon thing, because I was listening to something recently about cults and how a big part of cults is that they create their own language. And I was like, oh, uh-oh. But it's interesting. The other, because like it's so interesting thinking about the deliverer of the information and then the receiver, because I recently have engaged in a lot of stuff about math anxiety and how people just like shut, like the wall comes up the minute they sense any math approaching because of whatever previous experiences they've had. And do you think that's a factor too with the challenging? Like if people have had a negative experience of talking to someone about science, that can bring up a wall immediately.
Yeah, I think nobody likes to feel dumb.
Yes.
And so I don't think scientists intentionally are trying to make people feel dumb, but reflecting back on my own classes and stuff, even though I liked science, those are the most intimidating classes because they do have this reputation of being very rigorous and the people who do them are very smart. So people do kind of shut down because, it's intimidating and we're all humans and nobody likes to feel embarrassed or feel dumb. And we just do a poor job of that as scientists, whether intentionally or not.
Yes, and it extends to our own students as well. And, even those who come in trying to study science, to become scientists, those intro courses can be very, very difficult and can really pose a big barrier.
Yes.
And one of the things that I have been doing is just reminding students of where I was and kind of reminding myself of where I was as a student as well. And in fact, one of the things that a lot of people may not know about me is that I really hated chemistry as a high school student. So if you would have told me that I was going to be a chemist, let alone a professor of chemistry and biochemistry, I would have thought, you're absolutely crazy because this is not something that I like. I liked nature, I liked biology, and chemistry just seemed like this necessary evil that you had to learn. And so it's something that I usually lead with, especially in the so-called non-major classes. So people who are taking chemistry and it feels almost like an obstacle to their goal as opposed to a tool to what they need to become. And so I remind them of this story and I say, chemistry used to give me all kinds of anxiety and used to keep me up at night. But really it took somebody to take the time to explain things to me. And hopefully that's what we as scientists can do. To just guide people through and just say, there was a point in my life when I didn't know the things that I'm telling you, and somebody took the time to guide me through it.
Oh, that's so, yeah. Especially because there is this sort of narrative, and I really struggle with this as a physicist, that no, there's people who just came out at the, out of the womb super interested in physics and they were building telescopes, and that was 9,000% not me. So here, I think you kind of answered my next question. But what is your biggest tip then? So I'll throw it over to Maggie for communicating science effectively. So if listeners came away with one concept for how to be an effective science communicator, what would you want them to have?
Yeah, we're trying to summarize something that we wish people could walk away with, and it's really the idea of storytelling. Humans are, we're not all born physicists, but we're all born storytellers.
Yes.
And that's how we have communicated information for thousands and thousands of years. And so now as scientists, we've been trained to tell stories through data. And we were trained to do that. That's not necessarily innate, and storytelling is much more effective in getting people to understand material or to engage them in a topic. And so using storytelling as a primary form of science communication is a really simple approach and really lowers the barrier, I think, for people to not worry so much about, am I getting the data correct, but you're connecting with another human about a story. And getting them to engage with you that way.
Lovely.
Yeah, definitely the storytelling is very powerful. There's also the idea of just humanizing the scientist, humanizing ourselves, basically saying we're not really any different. We go home, we make dinner, we have children or, pets or other interests, and we're not just these robots or automated people who are just trying to tell you why you're wrong or why you're stupid. So really just kind of showing the humanity But in terms of just a tip in general, I think a lot of intentions of science communication seem to really try to push a certain idea of, I'm going to go and I'm going to change somebody's mind about something. And I would even challenge, and I think both of us here today, Maggie and myself, would challenge your listeners to, instead of going out there to change people's mind, is to really go out there and listen and to see where people are. And I've tried a couple of things in my classrooms to do something similar. And this was during the height of the pandemic. So it was 2020. It was the fall. There was a big election going on at the time. And everybody was at home. We were doing everything on Zoom. Everybody was wearing masks. And there was so much misinformation about the origin of the virus, about vaccines, and especially in the community where we live, where we're surrounded by rural areas. And misinformation can really spread very, very quickly. And the students in my class, which is an upper level biochemistry course, really, we started reading about misinformation. We started learning more about it, and they really wanted to do something about it. So I came up with a simple assignment that, maybe others can use as well, to just have students go out there into the community and talk to people within their family groups, within their friend group, and essentially to try to connect with someone that they know they disagree with on some sort of topic, and to try to connect with them on something that they do in fact agree with. So something like an interest, like pets, or your art, or some music that you like, and try to avoid, actually intentionally try to avoid the subject on which you disagree. And I made this for extra credits so that people are not really forced to go out there, and I don't want to put anybody in a place where they have to do something for a course. So this was optional, and again, because the students asked for it. And of the 15 or so students who decided to do this, only one was able to actually avoid the topic on which they disagreed. And everybody else, just for some reason, those topics came up because they were just really right at the forefront, because everybody was so charged at the time. And I said, if one of the rules of this assignment, if the subject comes up, make sure that you ask questions. Don't try to convince them of your opinion. Just find out why they believe what they believe, and just keep asking questions, and just find out what it is that they believe, and have them try to convince you of what it is that they believe. And sometimes just having that, it really teaches our students to be open-minded, to really go into an argument with the intention of having the other person change your mind. And I don't think that that's something that we typically do. So go in there and just say, I am really ready to see compelling proof that the earth is flat. And maybe someone will actually provide that for me. Now, I've not seen that. I've not seen any of it, but I have talked to flat earthers before. Both Maggie and myself have talked to flat earthers before. And just that having that open-mindedness and teaching our students to be more open-minded. But it also does something else. It really puts the burden of proof on the other person to really go out there and just find all the information they can and present it. And sometimes while they're talking, when you ask them more and more questions, you're asking them questions that they haven't really thought about yet. And this is something that makes them begin to maybe question their own ideas, or to just really go out there and read more about it or learn more about it. And one of the questions that you could ask them is, would you like more information about this? So one of my friends who refuses to take the vaccine, and that's fine, that's her personal freedom. She says, I don't want to put things in my body that I don't know about. And one of the questions that I asked was, would you like to learn about what's in the vaccine? I'm a biochemist, I can tell you, right? So these are the kind of questions that you can ask. And I think this assignment in particular had a really profound effect on the students, and I had them write responses on their experience, and it blew my mind as well, because of just the level of concern that the students had. It was very frustrating for them, but I think because it was frustrating, it really showed how they were able to understand the scale of the problem.
One thing that I really love is going out there and finding your something you do agree on with somebody you have a disagreement, that emphasizes our common humanity, and that we just because we disagree about one thing doesn't mean we disagree about everything. And it's so easy to somehow jump to that conclusion. And so I really love find something you do agree on. And it seems like with that baseline, now we can actually talk about something we disagree on with a little bit more, we do have this common humanity, and let me try to understand what you're saying. And I just love that. That's really cool.
And I think there's something like so unhelpful about being like, well, science is just facts, and shrugging at people. Like, it's so not conducive to conversation. And especially like we could see in the pandemic, so many things were genuine fear-based, that it's not people just being contrarians or whatever. And we also, so this is my guilty confession, that I am revisiting my teenage years by rewatching the X-Files. And it's very interesting to go back and be like, oh, where did all these conspiracies end up, and what? Like, because I absolutely adored it then and now. But it's so weird to see the genesis of all of these things. And then, but like airing things can only ever help. But just being like, nope, that's stupid, nope, like that just can't. Things fester and grow in... what am I trying to say? I was going to say in a dark, moldy corner, and I made a visual there. I don't want to stand by, but yes, if you know what I mean. So I love that.
And it also really emphasizes critical thinking skills on both sides. Like, we're going to have a discussion here. We're going to try to understand each other rather than trying to, just lay out all the facts. Well, these have been some great tips already. I imagine you have a lot of stuff you talk about in your science communication workshop and with all your science communication ideas. So what are some other tenets that you find make good science communication? What are some other tips you have for us?
I'll touch on some of the things we discuss in the workshop just as a launching off point. But, with social media, that's a huge platform for being able to do this in a way that's pretty accessible to a lot of people, and being able to create content that is engaging and catches people's attention. So, being able to use the tools that exist. We kind of talk poorly about social media and how it facilitates the spread of information, but that's where people are getting their information. So spending time, engaging with people in a way that's helpful, and tools to write a social media post or make a catchy title for a blog post, things like that are really simple things, but they're really good exercises that we help people work through to get their minds going on how can I actually communicate what I want to communicate to people in a way that's not boring or dry and is going to be effective. So that's kind of one component, is interacting with the public in a more broad way. And then we also have a lot of work centered around interacting face-to-face with people. And some of the things we've already touched on about just treating people with dignity, that's a big component of our workshop as well, is the dignity of people. And so, fear is a huge motivating factor, and just coming to terms with what motivates people. And we do a lot of exercises around that, and getting, because I think most of the scientists who engage in the workshop or who are looking for information about science communication, they are coming from a place of compassion and fear and frustration, and all of those put people in the seats of the workshop or have people tuning into a podcast like this. And so there's people out there eager for it. And it's really pretty simple to hone some of these skills and just get people trying things and being more comfortable and confident in engaging the public, I think. And Shahir, if you want to add anything else to that.
I just want to jump on the one phrase you had that I really liked, was treating people with dignity. And what does that look like?
I think, again, going back to this idea about people being motivated by fear and not shaming people for being afraid. I mean, I have 2 children, and, we've talked a lot about the COVID vaccine and stuff, things like that. But as I interacted with parents in my neighborhood on trick-or-treating a couple of years ago, they were asking me questions, and a lot of them were just afraid of what they were putting into their children's bodies, and validating that experience as a parent, that yes, you want to do the best thing for your child, and you are 100% a good parent by having these concerns, and really validating these human emotions that drive our decisions much more than data, and creating space for people to have all these experiences that they come into these conversations with. and not assuming that somebody is, out to get you, or just treating them as whole people, and then showing up ourselves as whole people really dignifies everyone's experiences and can begin to rebuild that trust that I mentioned earlier, that, we, I'm trying to think of a good way to phrase it, and maybe Shahir, you can jump in, because they are kind of squishy words, right? And I don't want to repeat a lot of the things we've already said, but just acknowledging those human experiences truthfully and honestly, and not pandering to people.
Right, and it's like you said, it's about establishing trust, because we listen to those that we trust, and they may not be the most knowledgeable people. They may not be right. My kids will listen to me, well, some of the time, but because they see me as a person of experience and authority, and many times I'm wrong about certain things. So one of the things that you can do is just encourage working together to find more information, and just saying, here's where my knowledge ends, but you bring up a really good question, so let's find out together. That really kind of makes it a teamwork, and really establishes trust, because you really can't work in a team not effectively without building trust. And this is very, very important when we're working with community, working with family especially, and I know Maggie has some experiences with that as well. And just fostering fascination. Again, going back to when we were students, when we were just beginning to become the scientists that we are right now. And why did we do any of it? It's because we were fascinated with something, because we had some sort of a question, and just respecting that dignity in somebody else, like Maggie mentioned, and understanding that they're really out there to get more information, just the same that we were, and just the same that we are every day as scientists, that we're interested because we're fascinated by something.
Can I say, this has blown my mind so much, because I have never, ever heard the word dignity in terms of education and communication. And it's so fundamental to the whole, and just building trust. But it's sort of wild. I don't mean that educators aren't honoring people's dignity and stuff, but it's just weird. I've never heard it explicitly stated. I think that's so powerful. And just what the thing you're bringing up, that to acknowledge that people may have had their trust broken, either through an experience of feeling stupid or whatever, but there's no point in pretending that, it hasn't happened. But the dignity aspect is huge. So thank you so much for putting that word on it. That's absolutely blown my mind.
So I have a question. You guys have been talking a lot about topics that are of interest in the public, that are hot topics that scientists might want to weigh in on. But what about things like your own research, and you're talking to somebody about your own research, or students in your class, and you're talking about whatever the topic of the class is? How do you incorporate storytelling and dignity and establishing trust and working together into those kind of conversations?
Maybe I could start. I think it was I'll pick up kind of where I left off, which is the idea of fostering fascination. Right? This is something that we try to do in many different ways. So we work with proteins. Maggie works with bacteria now, but also with proteins as well. But we're both really fascinated with proteins and protein structures, and we both never really saw a protein structure until we were in college, and it just triggered something. And because here's this fantastic structure that looks like it's out of this world, but it is in fact a product of this world, and that in itself is mind-blowing. And so this idea of fostering fascination is to just bring that excitement back into somebody's life, and to say, here is why this is super cool. And so if this person, you really have to understand your audience, and if this person is someone who really loves math, then put the idea of what you do in terms of math. Now, that might not be someone that you find every day, but if it's your Uber driver, or if it's your cab driver, again, that idea of jargon, get rid of that jargon, untrain yourself from talking in conference talk, and bring it back to everyday world talk. So when an Uber driver asks me, what do you do for a living? And I say, I'm a chemist, I'm a biochemist. And they say, what's your research about? I say, I study proteins. Proteins are these, they're delicious because they're food, because that's when you say the word protein in the public, that's what comes to mind, is that protein is like meat or a protein bar or, soybeans. And in fact, that is true. And you have to validate that, and you have to reinforce that, and you have to say, yes, it's protein. It's what we eat. But did you know that they also do amazing things in our bodies? They're basically the worker bees of the cell. They are, they're the ones who digest their food. They're the ones who transport things around. They receive signals from the air and from the water and from the light that we see. And they do all kinds of things. And because I'm a protein engineer, what I like to do is make them do things that they've never done before. And it's just that simple. I'm not really that interested in going into, serious biophysics with this person, because that's really not going to change their mind about anything, and it's not really going to impact their life in any way. But at the very least, they now have had an experience with somebody who's a scientist who's speaking their language in a sense. And maybe that fosters fascination.
Mm-hmm. That's great. I like how you start with the thing that the word means to someone who doesn't study whatever particular detail you might be studying about it, and then say, and here's some other things about it. That makes so much sense. I study chemical oceanography, and when you say oceanography, people think whales. And I'm into whales. I love whales, but I don't actually study whales. And so anyway, but I love the idea of validating that. Yes, and the whales need nutrients, and I do study this nutrient that, connected up that way. That's cool.
Yeah, I was thinking about this last night as well. For those of us who study things that we can't see with the naked eye, it could be difficult for people to really grasp. It's probably much easier for somebody who studies whales to capture somebody's attention, because that's something that people have a frame of reference for. But a protein or physics, those things aren't really as tangible to people in their daily lives. And I think you have to be a little bit more creative when you're talking about things that people have never seen. And even something like DNA, people are more familiar with that. They have an idea of what that is. But talking about proteins, it's just not something you encounter in high school biology. And for most people, that's all the science access they've ever had. So I think it's helpful to figure out, no matter what you're studying, understand where the limit of somebody's frame of reference might be for that. It's a little easier for me with, microbiology, bacteria. People have some frame of reference. So, but I think this particularly within these different, chemistry and stuff, the challenge is much greater to get people hooked in a little bit.
Well, I really love it. It feels to me like it's turning on its head. Like, I would normally think of it as a challenge. Oh, you say proteins and people think X. Oh, you say something about microbiology and it makes them think of this other thing. And now we have to say, no, that's not what we're talking about. But instead you're turning it into an advantage. Oh, you have heard of this thing. Let's start there. And now we've connected it to something interesting, and now we're getting a story here. And so I really love, it just feels like you're creatively turning a challenge into an asset.
Can I ask you if you have advice for nervous communicators like me, who, I'm scared of the general public, because I'm always scared they're going to ask me something about nuclear physics, or the Higgs boson is my big party anxiety thing, because I can't with particle physics. But, I get really, I'm I don't want to open that can of worms in case someone asks me stuff I don't know and I'm going to look stupid. Do you know what I mean? And part of me, when you were saying it, I was like, how much of us use jargon as a protector? To kind of okay, well, I'll just, babble on in this sort of weird language. And then there's So do you have any advice for people who would get freaked out that they're going to get asked something they don't? You know what I mean?
I think saying I don't know is one of the most powerful things we can do as a scientist, because, we're so specialized that people don't understand that that's what you do when you're getting a PhD or going on to further education, you're becoming hyper specialized in one specific thing, and people don't understand that that's the process. And so I think just saying, I don't know, I would love to learn more. And that's really not what I study. Let me tell you what I actually do study, because there's more to this field than the big things that make the headlines. And I'm always super, I can relate to feeling nervous that people will think I'm stupid, or I'll get asked questions I don't know from, I get asked all kinds of bacteria questions that are way outside of my scope of research. And just saying, I don't know. I only have learned these specific things, and I'm happy to tell you more about those. And I just think, again, humanizing the scientists, that we're not these all-knowing, robotic creatures that you might see on TV that have these computer brains. We know what we know, and we're really trained as scientists to learn information and to understand information, and we can share that process with other people by saying, I don't know, but here's something else interesting you might not know about physics.
I totally agree. I actually really love saying I don't know when someone asks a question in a class. I feel like that's helpful for everybody to understand it's okay,
Yes.
It is very helpful, and I think it's also about changing that narrative. Like Maggie said, it's this idea that we know everything. In fact, none of us would have our jobs if we knew everything about science. And I don't think that's quite advertised very much to this general public, that we are scientists not because we know, but it's because we don't know.
Yeah, we're studying. I mean, I agree. That is, you take an intro class, or you take classes in high school, and you learn all these cool things that we all know and that are established, that the community knows, but that makes it suggest that the scientific community knows pretty much everything about how the world works, and that's obviously not true and is very misleading. So it's very helpful to that's what we're studying, is we're doing research because we don't know.
Yeah, if I knew, I wouldn't have a thesis project to be working on right now.
yeah,
I'm grateful I don't know.
Well, I really love this. Storytelling, fostering fascination. Those are some words that have really stood out to me that you guys have talked about so far. I guess I'm really curious about, in your classes, or like thinking about you're talking to a group and you want to tell a story to convey some piece of information. Can you give an example of what a story would be? Are you talking about connecting it to something that they know? Like you were talking about proteins. People know protein is, in animals and good for eating. Or are you talking about connecting it to a story, like your personal story, or what kind of story are we talking about here?
I think for the most part, Shahir and I really emphasize personal storytelling. So telling stories about our own lives, whether that's, a childhood memory, or sharing details of a family member who was sick and died from a disease that's protein related, right? Being a bit vulnerable in your storytelling, can really get people interested, because what's going to stick with them is you have to decide what you want them to leave the room with. And it's not necessarily that, Alzheimer's is caused by a specific protein, and it misfolds and it causes this. It's that, this disease that affects so many people has some scientific relevance, and it gives them just a little bit understanding and grounding in something that might be happening in their own lives. And they walk away with a little bit more knowledge and a little bit more confidence in their ability to navigate maybe the medical system dealing with somebody with Alzheimer's. So using that human-driven story can really get people to latch on, and then you can give them the information that you want them to know. And it's not going to be super detailed, but they're going to remember. So from my own life, I talk about my grandfather who has Alzheimer's, and just being able to share that story, people can relate to that so much more than if I were to just kind of talk in more generic terms about this disease. And so, it's scary to be vulnerable, but I think that that's always a more powerful way to interact with people that you're trying to get them to come a little closer to you and your information, and you want to just share that with them.
I love that. And I kind of, because at first when you said storytelling, I was like, because what's the word called when you give inanimate objects, like anthropomorphizing? Is that the word? Yeah, I do that all the time about stupid physics things. Like, and so I was like, are we talking about that where we're like two electrons or walking down the street or whatever? But yes, this makes a lot more sense. So getting the connections.
It doesn't even have to be something so vulnerable as a disease. When I talk about my bacterial research, which I study bacterial interactions and how they share food and how the environment impacts their behavior, I start by saying, in my home, I am mom, I am partner. And when I move to a different environment, I have different interactions. I behave differently. When I'm in my front yard and my neighbor is yelling at his dog, who's also named Maggie, that's going to cause me to behave differently. And so just it can be something that people relate to, moving through the world, and we change, and bacteria behave the same way. And that's what I'm interested in studying. So finding something that's very common, whether it is losing a loved one or having a weird neighbor, can just bring people in and kind of level the playing field and make them understand the basic ideas of what your research might be. And I think, communicating your own research, I think, is probably the hardest thing. It's much easier for me to talk about something that I don't actively do research on. Mm-hmm. Like I don't do biochemistry, protein engineering right now, but your own research that's very personal and that you like live and breathe, coming out of that and losing all that jargon, I think is definitely more challenging because it's a big shift in your mindset when you're, writing a manuscript one day and then having to talk to high schoolers or something the next day.
Yeah. It's hard to even remember what is jargon when it's the stuff that's so personal that you spend so much time with.
Yeah. And so I think just kind of like when I physically did that, that's how it feels, like lifting yourself out of it and putting yourself physically in another environment for a little bit to kind of rehumanize yourself a little bit. I think is really important.
I think so much, like just from talking to students, I feel like we miss so many people who could be doing science because they feel like they have to leave all of their human bits at the door, and that being able to chat about like, oh, well, why are you doing this research? Well, my grandfather has this situation, like those things. That's so lovely. And it's so lovely to model that for people. I'm sure it's really impactful.
Yes, that is absolutely a big problem in science. I feel like we really lose out on a lot of creative individuals because, they're told one way or another, even if it's just, from TV, that to be a scientist, you have to abandon all creativity. Yes. When really creativity is the drive for innovation, but that's not something that's, it's really a very well kept secret, and it really ought not be. So, yes. So what can we do about this? And this kind of leads to something else that Maggie and I do in terms of science communication, which is using art to communicate science in general, but specifically, proteins and living things in general. And again, this goes back to protein structures and how they have these amazing, just kind of very strange, abstract looking structures. So illustrating those, but also illustrating something that's a little bit more narrative, something that's a little bit more relatable. And just showing how proteins are just such an essential part of our lives, but not just our lives, but animals, plants, fungi, bacteria, everything around, as well as how they're really not that different from who we are in terms of that social interaction that they have within the cellular environment where they live. So using art as a form of, again, fostering that fascination is just another aspect that we've been working on for a few years now. And it's also another aspect of our workshop and kind of trying to change that narrative a little bit to make scientists a little bit more open-minded to using art in their own classrooms or in their own narrative, or at least just every day doing a little bit of art, no matter what form it is, to kind of really start thinking about your own issues, your own scientific problems in a different way.
I love that, especially since we usually don't think of art going with science, and so it's really helpful to see that connection and the value of connecting it.
Yeah, Shahir always in the workshop talks about how a majority of Nobel Prize winners are proficient in some art form, whether it's music, drawing. So they are, good science is pretty commonly linked with very creative individuals. And a lot of times, yeah, we do lose out on very creative people from diverse backgrounds who bring a lot of different perspectives into, bench work and figuring out problems. And I think giving scientists and the general public the freedom to look at science from a lot of different ways shows people that, I'm just because I'm not, the standard scientist I might see on TV doesn't mean that I don't belong there. And there's lots of ways for me to do science that are going to be validated by this kind of new. I mean, there's a lot of people doing this kind of work, so it's not just us, but there is this wave of increasing creativity and diversity and how that will actually enhance science so much, I think. And it just takes somebody getting out there and saying, yeah, well, let's draw our research. Let's see what we can come up with that's different and new. And
sure.
It's more people deserve to be able to do that, I think.
This conversation is very soothing to me. Like, as a scientist, because I often feel like, well, I'm not like Sherlock Holmes, and but this is very soothing. And it's funny because Claire, I have read blurbs about Claire's research lots of times, and then it was when she did a really effective drawing. Remember, we were on a beach talking to students, and you did an amazing drawing about upwelling, and I was like, oh, this is it. And it was so, like, that's when I had my magic moment where I was like, now I know what Claire does. So yes, but we don't ever talk about drawing or diagram drawing as like an important part of science. I mean, I know we're talking about more creative other formats too, but even just that part of it, that is something we all do and never specifically mention.
You know what it's reminding me of is this style of poster that I saw recently. It was before the pandemic, but so I wonder if it's still a thing. But it was like, instead of, the normal poster that you have at the scientific presentations, intro, methods, results, discussion, packed with text and visuals and but then the new poster was like, what if we just had, what's the key takeaway you want the person to have, and we'll just have that huge, and then there's more information if you want it, but it's really obvious, glance at the poster, what's the takeaway? And I just really like the idea of, we'll just have a visual, we'll really think about what we're trying to communicate, and we'll have it there. And that I guess I'm feeling this is connected just because of the idea of having an art, having a visual, and really thinking about what are you trying to communicate.
Yes, absolutely. Very important, the visual aspect of it. And this is why I personally, and maybe a lot of scientists feel the same way, I would personally love to sit through several good presentations rather than read one or two papers about the science that's being presented. The paper is going to be there to show me the data and how good the data are. And if I want to replicate the experiment, what the conditions are, what the buffers are, what the machines they used, whatever it is. But I want an engaging speaker. I want someone who's going to make me excited about it. And that's not something that most papers, and at least in our current system, are designed to do. Right? There are very few papers that I read and I said, and I kind of stood up and said, "Hooray! This is great." Very, very few. Right? But there have been really inspiring, and I think we can all relate to this, really inspiring talks by really good presenters who knew their audience and just really got us going on what it is that they wanted us to be excited about. What do you want your audience to know about? What do you want them to do about it? Right?
Can I ask you, do you think that this would be should be part of science curriculums then in degree programs? Because all I did was do a trial run of a talk and people kind of booed or clapped and that was it. That was the feedback. But just to really convey, because I think we've all seen the consequences of ineffective science communication. So because I don't know, I haven't heard of that as being an integral part of degree programs or requirements, that there is a science communication. Have you guys had any traction on that front?
I can just speak about my experience. I'll let Maggie speak about hers as well. But I'm lucky to be in a place that encourages this kind of work. and also in a place at Indiana University South Bend where class sizes are small. And even though we're kind of being dinged on these things, oh, why don't you have more students in your class? I think it's also fantastic for the students, because then instead of having them write papers or do just an exam with multiple choice, because I can't sit there and just grade hundreds and hundreds of exams, what we're allowed to do, or what we're capable of doing, is have students do presentations, and really kind of instead of just testing their talent, because everybody's just has different talents in terms of personal, in terms of being a public speaker. It's really about giving students guidelines on how to do a presentation well. And here are some of the tips. Make eye contact. Here's what you should do, and really goes down to here's what you should put on slide number 1. Here's what you should put on slide number 2. At least early in the semester, and then later on they develop these skills. And also reminding students and making it a point that you're not being graded on your talent. You're being graded on how much you learn and how much you follow these steps and these tips that I'm giving you on how to be a more engaging speaker.
Yeah, as a graduate student, at my university, there's not any required science communication training. I do wish that was different, because I think it is really important. And I'm very grateful to have an advisor that has been really supportive of me getting my own training. I've participated in lots of workshops and, spent time away from the bench to invest in my own ability to do this. And I think, we can't just demand that a course be, implemented. But I
Yes.
think as, as URL professors, allowing students who have that interest to be able to do it, I think then we just kind of creates this chain where supporting students who are very interested and want to pursue getting better presentations and are invested in science communication, and supporting them, then they can go on and continue to spread the importance of it as well. And our workshop has been hosted by several different universities, and here at Notre Dame, we've given it twice to 2 different student organizations. So I think it's clear, and those were both invites from graduate students. So I think it goes to show that students now want this, and it should be implemented more. And I don't have a great idea of how that should be done. And I think both at the undergraduate and graduate level, there's huge benefits to giving people tools to give a good academic presentation, to give a good general public presentation. Those tools are invaluable, and they're not being taught explicitly unless you are lucky enough to have an advisor who's very good at it as well, or good people around you to help. So I can just feel the pulse that people are hungry for this, that are coming, and I think there will be changes made.
That's great. I'm really curious. So, well, first of all, you're talking about your workshop, and it sounds awesome. And how could interested listeners bring you and your science communication workshop to their university if they wanted to?
Yes. So just to kind of give a little bit of a summary, we talked a little bit about different things that we do within our workshop, but we really focus on 4 main things. One is just kind of interacting with people that you do know, and dealing with misinformation in general, and like family, friends, that Thanksgiving dinner, and talking to people that you don't know. So presenting yourself, having that confidence in who you are and knowing where your expertise are. And then communicating through writing, so maybe blogs or social media, or writing an op-ed or something like that. And then finally communicating your research in different various art forms. So those are kind of the 4 main components, and it's not just for STEM scientists, but we've had attendants who were from the humanities, from English, sociology, and mostly PhD students, but also early career scientists, or just any stage of your career. But we tend to have, as Maggie mentioned, more participation with the younger scientists, because I feel like there's a wave now of seeing how important that is. So, and if anybody's interested in this is about a 2-hour workshop. they can go to our website, which is foldingmoonlight.com, and just click on the workshop link page, subpage. I don't know. It's
on our website. There is a banner for the science communication workshop that has more information about what's included in the workshop, more about us as well, and some comments from people who participated in the workshop and the things that they got out of it.
Is there any chance you have a grant that supports you coming to Ireland to do this? Is that just checking? But this all sounds so good.
Yeah. Well, we have to give some credit to some of the people who have supported us in developing this. So part of the work has been supported. We don't have to grant anymore, but was supported by the Burroughs Wellcome Fund in North Carolina. They are really, really interested in science communication, especially that intersection of science and the arts. And of course, the Cottrell Scholars, the RCSA, Research Corporation for Science Advancement, have been really supportive as well. And NSF, Maggie as well, supported by NSF GRFP, they're really interested in that as well. So it's been really great to see the different organizations and the different funding agencies really interested in this kind of work. So we're really optimistic and hopeful that hopefully this will be a model for many other people to do and to follow through. And really, the key here is don't be afraid to ask for support for this kind of work, because sometimes granting agencies are saying, oh, we were just waiting for someone to do this kind of work. So, and this goes to anything, but we've tried it with science communication. We just knocked on some doors, and people have been very, very supportive. But we don't currently have the money to actually go to Ireland, but that would be fantastic.
And we have done the workshop virtually several times, so that is an option if that's more feasible and doable for people.
Well, this has been super fascinating, guys, and I just want to end with a question. Is there anything that you wanted to talk about that we didn't incorporate into our conversation? Any tips that you have that we missed, or areas that you wanted to cover that we didn't get to?
Connect with people without any intention of trying to teach them about science, just to get to know your community. We can get isolated in our universities and labs and conferences, and the community needs us out there as well, and connecting with them well beyond whatever our research topics are. And that will also create trust and create a better sense of community. The people that we have to live with and in the cities we live in are the people that we can have the biggest impact on.
That's so beautiful. I feel called to action. I'm going to try to stop being scared of bringing up science, because and I love, you kind of articulate, we can't logic our way out of this, and just throwing logic or whatever at people is not going to do the thing. And I just love this whole human community just all of the things you're saying is so warm, which is also not a word that we often associate. Warm dignity with science education. So and communication.
Well, thank you very much, both of you guys, for being on the show and having this great conversation. Thank you.
Thank you for having us. This has been wonderful.
Thank you so much. This is we're always so delighted to be able to talk about what we do.
Thanks so much for joining us on the Professor Podcast with Ruth and Claire. We're delighted to have you as a listener, and we would love to hear from you. And if you want to email us, our address is contactprofessorpodcast@gmail.com. We'd love to hear any of your suggestions for future shows, or professor quotes that you might want to share with us, or even just things that have come up for you when you were listening to previous episodes. And if you've been enjoying the podcast, we would love if you would spread the word. So the best way to spread word is by telling people if you think they should listen to it, or you can leave us a review wherever you listen to your podcasts. Thanks so much for joining us, and we'll see you next time.